In this first video on graphing rational functions, we are going to explore the graphs of rational functions that are variations on this basic rational function, which is y equals 1 over x. So the parent graph for this function, you'll recall, is a curve that approaches the x axis and the y-axis in the first quadrant and approaches the x and y-axis in the third quadrant. That is the parent graph for many of our rational functions. So rational functions that are variations on this theme might look like this. Let's say we have f of x equals 3 plus 1 over x. Well, I am adding a number to a function, and anytime we add a number to a function, then we move the function 3 units up, or whatever that number is. And in our case, it's 3. So I'm going to draw my x and y axis here, and my whole function is going to move 3 units up. Well, rational graphs have asymptotes. This particular rational graph, basic rational graph, has the x-axis and the y-axis as its asymptotes. So what I'm really doing is moving the horizontal asymptote up 3 spaces. And that's what I'm going to do first. I'm going to sketch in my asymptote as a dashed line, and of course this is my vertical asymptote. And so my curve then is going to be up here. Once I move my asymptotes, then I'm ready to sketch my graph. We can also vary this rational function by having a number in the denominator with x. So let's say that we have x minus 2. All right, well, when I graph this time my vertical asymptote moves over to the right 2. So this is still my horizontal asymptote, but my vertical asymptote is now right here. And my graph then is over here. All right, well, let's do a combination. So let's say h of x is, let's say 1 over x plus 1 minus 2. Now, in this particular equation, we see that we are subtracting a negative 1. Subtracting a negative 1 is the same thing as adding 1. So we're subtracting a negative 1, which means that my vertical asymptote is going to move over to negative 1. And we are minusing 2, and so that means my horizontal asymptote is moving down 2. And my new asymptotes are here. Therefore, my graph is going to look like this. Now you want to make sure when you graph these that your curves hug those asymptotes. Don't have your curve curving around back like that. That doesn't make any sense. All right, and then we can do one more thing with these takeoffs on this parent graph. Let's erase this one. You can throw a negative sign in there. All right, so let's suppose that our new f of x is f of x equals negative 1 over x plus 2. Now, that means that I've got 2 things going on. First of all, horizontally, this is x minus negative 2. So horizontally, I'm going to move to the left 2. That means my asymptote moves over here. My horizontal asymptote is the same. But this negative sign means that I am going to reflect my graph across the x-axis. So instead of being up here, this portion will now be down here. And instead of being down here, this portion will reflect up here. If I were to put the negative sign in with the x, then we would have a graph that would reflect across the y-axis. Now, that's not really the best way to say it, but that is the way it is said. So let's suppose my new g of x is 1 over 4 minus x. All right, I have a negative in with my x. In order to really understand this graph, I am going to have to rewrite this as 1 over, and I'm going to factor a negative 1 out of this entire quantity. So this becomes negative 4 plus x. You see, negative times negative gives me positive 4. Negative times positive gives me negative x. So this is, in fact, the same thing as this. I've just rewritten it to pull the negative out, and I'm going to rewrite it one more time so that it looks like this, negative, and then in here I'm going to put x minus 4. So what happens is my negative sign is now here with the x, and when I graph this, I see that horizontally I move 4 to the right. My horizontal asymptote stays the same. Normally I would be here and I would be here, but this time I'm going to, because my negative sign is with the x, I'm going to reflect my graph across horizontally. My positive x's are here, my negative x's are here. So you reflect your graph this way. So this part of my graph over here will actually be over here. And this part of my graph here will reflect across this way horizontally to be here. Now, if you think about it, it really wouldn't have mattered if we had reflected this way or reflected this way. We would have gotten the same graph. And you can tell by looking at the equation. We can also write this equation as negative 1 over x minus 4. So this particular function, because it is an odd function, look at it, you see it is not an even function, it is an odd function. And so it doesn't really matter whether the negative is with the function or with the x, the result in the picture is the same either way.